Hello guys, welcome back. Today we are looking at the ideal machine. A ideal machine can be called a perfect machine. What do you understand by the term ideal machine? Ideal machine, these are machines which are work input it is equals to work output. There's no energy loss because friction it is neglected, okay? But in actual sense, in every machine, there is a friction and heat. But for ideal, uh, let's just take it as a this is just a lesson for ideal machine. Okay, so now we have this question outlined down here. A car lift has a movement of ratio of, so you have to write down the data for you to answer this kind of question. This is data, and for those who don't know this topic, it is in engineering science. Okay, I've just introduced another topic for engineering science. Okay, so now a car lift has a movement ratio of 6. So this is a velocity ratio. Okay, so velocity ratio we have as a 6, and the velocity ratio we all know that is the ratio of the move of the distance of effort to the load to the distance of the load. Okay, and can and this same car can lift a mass of, this is a mass, so can lift, that means it is a load. So the load we're going to denote it as 900 kg. Okay, uh, when the effort it is 200, so effort we are going to denote it by using uh, by using E. Okay, which is 2000 Newton. Okay, and from our this question, for A, we are told to calculate the efficiency of the lift. B, effort required to overcome the friction. Then C, the work done against resistance if there is raised to 1.5 meters. Okay. So for us to calculate efficiency, we all know that the formula for efficiency it is the efficiency it is equals to mechanical advantage over velocity ratio times 100%. When we are told to calculate efficiency, you are told to calculate the percentage of such particular machine. Okay. So for us to find efficiency, we have to find the mechanical advantage. From this data which we have, we can find a mechanical advantage. We all know that mechanical advantage it is equals to load over effort. Okay, and remember this we have 900 kg. Okay, and this unit for load and effort should be in the same unit. That means we have kg, we have to take it into Newton. Okay, so we have to multiply by 10 for us to have 9,000 Newton. Okay, so now this is a load which we have, which is 9,000 Newton for the load, and for effort we have 2,000. Okay, this is 2,000. Then when you cancel these three zeros, so mechanical advantage has got no unit. Okay, so we have found that mechanical advantage it is equals to 2 into 9, it is 4.5. Okay, 4.5. This is our mechanical advantage. So this is where now we can find the efficiency. So for A, we are finding the efficiency. So the efficiency is denoted by this symbol. For mechanical advantage, we have found that it is 4.5. Then for velocity ratio, we have 6. Then you multiply by 100%. Okay. Then 4.5, you divide it by 6. Okay. 4.5, when you divide it by 6, you're going to have you are going to have you are going to have 0.75, you multiply by 100%, in which you are going to have 75%. So this is the efficiency of this ideal machine. Okay. So now, since we have found the efficiency, let's find the effort required to overcome the friction now. Okay. Let me just make a space here. The way we can find the effort required to overcome the friction, it is that ideal. We have to find the ideal effort, and then we are going to subtract ideal actual effort minus ideal. Okay, that's when you can find the outcome friction. Okay, so in which we're going to say ideal effort should be equals to load over velocity ratio. Okay, this is a formula for finding the ideal effort. Okay, in which it will be load, we have 9,000 Newton. For velocity ratio, we have 6. Okay, in which it will be, so now we are finding B now here. Okay, so we are going to say 9,000 divided by 6, in which you are going to have 15,000. Okay, Newton. This is just ideal effort. Okay, then the actual effort which we have, it is this one here. Okay, so we have to subtract ideal actual effort minus this one. That's when you can find the effort required to overcome the friction. Okay, so in which we are going to say effort required. Okay, effort should be equals to actual. Let me make a space here. Okay, effort should be equals to actual effort minus ideal efforts. I hope you have seen how I found ideal effort is found by dividing load divided by velocity ratio. Okay, then you subtract from the actual effort which we have here. Okay, so in which it will be equals we have 2,000 as the actual effort, 2,000 Newton minus 1,500 Newton. When you subtract, you are going to have 500 Newton as this is the effort required to overcome the friction. Okay, this is the effort required to overcome friction. So now let's move on to question. Let's move on to question C now. For B, we have found that it is 500 Newton. Okay, so we all know that work done, it is equals to load times the distance, or force times the distance. The load represented by force, then the distance we have. Okay, the distance we are given that for C. Now we are finding C. Okay, we are finding C. Work done against resistance if there is a raise to 1.5 meters. So what you do, load, we have found that it is 9,000. Okay, in which we are going to multiply 9,000 multiplied by this because there is a raise of 1.5 meters. of this machine, okay? 1.5 meters. Then now let's find the answer, okay? 9,000 times 1.5, you are going to have 13500, okay? This is the work done, okay? So now we all know that efficiency, there's other formula also for finding the work done, because here we have to find the work done against the resistance, okay? Here we have just found work done, so let's find the resistance of that machine, okay? So we're going to say efficiency to be equals to work output. Work output you divide by input, then you multiply by 100%, okay? All right. Then now what you are going to do in this one, because for input we have so in which we're going to multiply, so we are going to say here, we are going to say, let me just create a space here. We all know that ideal effort, this effort required, we have found that it is 500 Newton, okay? Now let's find the work output, okay? So we are going to say efficiency times the input, you cross multiply here, okay? Which should be equals to work output times 100 times 100, then times 100, okay? Then here work input we don't have, work output we were found that work done, this is the work output here, okay? Work output, okay? This is the work input which we have here. So we are going to say the efficiency from that previous, the efficiency which we have found on Earth, it is 75%, okay? Then let's denote input as or X, okay? Because we're finding input, work input, okay? Which should be equals to 35,500 Newton. Then you divide it by 75 by 75%, in which X it will be equals to when you divide this one 13,500 divided by 75, you are going to have 180 Newton as the work input, okay? This is the work, this is the work input, okay? This is work input now. Oh, here, sorry, I've made a mistake, because you have to multiply this one times 100, okay? Times the 100% which we have here, okay? So we're going to have two zeros here, okay? In which you're going to have 30, 13, 15, or 13, 13,500, 00, then you divide it by 75, you are going to have 18,000, okay? You are going to have work input, you're going to have 18,000, okay? This is the wake input. So we have found the wake output and the wake input. Now let's find the wake done against the resistance. So you have to subtract this the same wake input minus minus the wake input minus the wake output. Okay, the wake input should be greater than wake output. Okay, if you find that wake output it is more than wake input, that means you found the wrong answer. Okay, so let's try to create a space here. For this one, we are finding C. Okay, so now wake done, it will be equals to wake input, wake in minus wake out. Okay, in which we're going to say 18,000 minus 18,500 Newton. Okay, in which you are going to have minus 13,500 you are going to have 45,000 Newton. Okay, this is wake output. This is the wake done against resistance. This is for number C. This is the answer for C. I think this is where we end. For those who don't know what I introduced today, it is engineering science. Engineering science, it is for those who are doing engineering courses. You can find it. You can find this week as a helpful thing. Don't forget to subscribe and turn on the notification bell so the next time you see the new update. Thank you. See you next time. Bye bye.